the enhanced convergence in turn will generate more condensed water and the resulting precip enhancement within the valley region. Okay, so I think the further detailed analysis of radar observation will be required to validate this hypothesis. The second question is why the narrow barrier can produce more intense precip than wider barrier. Okay, and this is a unique or common feature in the typhoon environment. I think this at this stage the question is still unanswered. However, we may recall a case from other typhoon, Shang. Okay, and this typhoon is from study by the UN Cheng in 2008, and this study also showed that the much more intense precip occurred over the narrow and the lower barrier. Okay, so it seems to me that at this stage, okay, the narrow and the lower barrier may have a higher potential to produce the more intense precip in the typhoon environment. Okay, this is preliminary finding for Morakot, and the upstream southwesterly flow was strong and persistent with maxima 30 to 40 meters per second near the surface level, and the corresponding trend between the intensity of instant oncoming flow and the area mean intensity of orographic precip. Okay, I think the final the finding is that the extent and degree of orographic enhancement depends strongly on the local terrain feature, especially this feature cannot be easily determined by the upslope lifting, and we are undertaking the more analysis for this event, and in attempt to try to identify the specific mechanism contributing to the orographic enhancement for this particular event. Okay, this is all I have. Thank you.
Professor Yu, I think this is a very detailed analysis that gives us a lot of learning. Any question? We can take two, no problem. Okay, Professor.
Have you tried to map the landslide areas with your detailed precipitation analysis, like with the Xiaolin village?
Not yet, but we just doing this analysis, and I just have my student to do this kind of the comparison. The most severe the damage and related to the precip distribution. I think I will do this in the near future.
Sounds pretty useful.
Yeah.
Any other questions?
Hi, can you go back to the one of the figures you were showing where you show the maximum in the valley regions you were talking about?
Yeah.
From the radar, please.
Okay.
That's a good question based on that.
Yeah.
Okay, that's a conceptual model. Can you go back to the actual radar analysis? You showed several, I think, and you pointed out the isolated spots of rainfall maximum. Okay.
Yeah.
Yeah, any one that you were talking about.
Okay.
So given the conceptual model you just showed from House,
Yeah.
is the orientation of the flow relative to these valleys consistent with what the conceptual model was showing?
We have done an analysis for the relationship between the wind direction and the precip intensity over the mountain region. We see when the wind oncoming flow become more parallel to the local ridge, and this kind of mechanism seems more significant. However, when the upstream oncoming flow more normal to the barrier, and this kind of mechanism seems not very significant. So we have already see some clue for this, for the it's kind of very sensitive for the wind direction.
Okay, thank you. I have one comment. Is this shallow and the narrow terrain can have an even bigger rainfall frequency?
Yeah.
But can this explain the Taimali disaster?
So sorry, I don't know exactly where is the Taimari. you can. On the lee side of the mountain. Okay. Actually, when we look at this side, we must be very careful. Because over this region, the radar beam is pretty high. Yeah, so but I think we will use we haven't used the rain gauge data to correct the radar the right rate. But I think if we done this, and we can more confident to say, oh, what's happening here. Yeah. But there are some trend. The heavy precipitation is just downstream of the mountain crest. Yeah.
It's the end of this
Lunch is ready outside the meeting room, and the afternoon sessions will begin at 1:20 p.m. And all the invited speakers